developed by ATOS, is one of the data management platforms used in Marvel. It is based in the Apache NiFi ecosystem. Apache NiFi is an open-source tool that allows an easy creation of advanced data flows both for static and real-time data. DatAna is deployed in the Marvel infrastructure, allowing data communication, transference between Marvel nodes, and transformation of the results of the AI inference modules to the Marvel data models, based on Smart Data Models initiative. The main inputs of DatAna are therefore streams of AI inference results, while the outputs are those results normalized and ingested to the Kafka topics prepared in the Data Fusion bus, another of the data management platforms. Let's have a look to the components of the DatAna framework. The main building block is Apache NiFi. It is available as a service in Kubernetes using Mavdash and Helm charts. Instances of NiFi are deployed in several layers, such as in the Marvel Cloud, Fog and Edge in the pilot's infrastructure. Mosquito MQTT brokers, with instances deployed in all layers next to NiFi, act as a bridge to decouple the components' interactions to facilitate integration. For the next iteration, we plan to also deploy Apache NiFi for the edge. Apache NiFi registry will be also delivered for version control of the data flows defined for the use cases. DatAna has been used in the implementation of all Marvel use cases. It transforms inference data streams to the smart data models for events, anomalies, and alerts based on the inputs provided by several inference components concurrently in the different edge, fog and cloud layers. The processed data is finally made available to the Data Fusion bus in the cloud via specific Kafka topics prepared for the use cases. In this demo, we are going to demonstrate how one of the Marvel inference model, in this case the VCC, sends data to DatAna and how DatAna processes the data before sending it to the DFB. Let's have a look first to the design panel of the NiFi user interface. NiFi helps to define data flows and pipelines with almost zero code effort by dragging and dropping, and configuring specific computing units called processors and making connections among them. In Marvel, we have defined specific data flows to handle the data coming from each of the inference modules for DatAna. Most of the inference modules have similar data flows deployed in all the NiFi connected in the different Marvel layers. Let's go deeper in the data flow for the VCC as an example. The flow is easy to follow from a bird's eye view. It is composed of several data processors that perform specific functions. The first block is getting the data from the right MQTT topic and setting up some attributes for the entire flow. There are several blocks that perform specific validations, such as checking for mandatory fields or the range of accepted values. The data is then transformed to comply with the specific data models. The Jolt processors have the transformation rules specified for the VCC as it can be seen on the data flow. The last step consists of sending the transformed data to the cloud NiFi using the NiFi site-to-site protocol. This data will be received by the cloud instance of NiFi defined in the last processor and then sent the appropriate Kafka topics of the Data Fusion bus for further processing. Now let's perform a quick execution of the flow with sample data. The first connection shows that there is a queue of data waiting to be processed. This is because we have stopped the processor for demo purposes, and NiFi queues the data to not miss any information. We can see the data in the queue by selecting the specific entry and browse the content, in this case a JSON file with sample data from the VCC. Now we play the processor, and the data passes through the rest of the processors. We have stopped the last one before passing the data to the cloud to have a look at the queue of processed data. We can see one of the results, correctly formatted as a media event type according to the smart data models. If we run the last processor, the data would be moved to the cloud to be sent to the DFB Kafka, to be further refined and stored in the final data management platform of the data inference pipeline. In a real-life demo, all these things are automatic and occur in real time at high throughput rate.